Hey guys, welcome to our video lesson on solving quadratics with the quadratic formula. In this, we're going to use the quadratic formula to find x values where a particular quadratic equation is equal to 0. So when we would use this is typically when you can't factor. If it's something that would factor where you could get two numbers where the product was -8 and the sum was -4, that's a quicker way to do it. It's more efficient, and it's something that we build upon throughout the next couple of math classes that you're going to take. However, it doesn't work all the time. The universal way to do this is using what's called the quadratic formula. So, what is the quadratic formula? The quadratic formula looks like this. It's a big formula. It looks a little intimidating, but a little bit of practice, it's really not that tough. I will say before we get into examples that with this, typically the students who have a tough time with this are the ones who try to plug this entire thing into your calculator, and I'm going to show you a way to do this really with minimum calculator use. That's typically the best way to do this, the least number of mistakes. All right, so we've got a lot of stuff here. We've got these A, B, and C's. What do they mean? They come from this, from an actual quadratic equation. Now, a couple of things I want you to notice. One is that this only works when it's equal to 0. So in some cases, you're going to have to work both sides of the equation to make one side equal to 0. Then the A, B, and C, they come from the numbers that are out in front, called the coefficients. So the number that's in front of the x squared, the number that's in front of the x, and then the number that's just all by itself without an x. So all we really have to do is get the equation into this form, standard form, and then take this, whatever number is in front of the x squared, and put it here and here. Take whatever number is in front of the x, put it here, and then take whatever number is without an x, and put it right here. So what does that look like? So solving this one for our first example using the quadratic formula. The way I like to do this is I like to write out what are A, B, and C and then plug them into the formula. So A would be equal to 1. If there's no number in front of this x squared, which is super common, that means that the coefficient is equal to 1. B is equal to +10. And C is equal to +9. Now this one's kind of nice. It's already in standard form. It's already equal to 0. I don't have to do anything to it. I just have to pick out A, B, and C and plug it into the formula. All right, so what does that look like? The formula is -b, so change the sign of b, so -10 plus or minus the square root of b squared, so 10 squared, minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 1. Now again, I would not start this by just plugging this all into my calculator. The first thing that I would do is just plug in this part here. This is called the discriminant. So just the part that's inside the square root symbol, plug that into your calculator and then rewrite it. So don't even do the square root part. Just plug in the numbers that are inside the square root symbol. All right, so that's going to be -10 plus or minus. If you plug all of this in, you should get a +64. And then 2 times 1 would just be 2. Now, either you can do square root of 64 if you know it, you can just write it down, or plug just that into your calculator, and we get -10 plus or minus 8 over 2. Now notice, as we're simplifying this, we've got this plus-minus symbol. That means that for a lot of these, there's going to be 2 answers. The first one is going to be -10 plus 8 over 2. -10 plus 8 is -2 over 2, and that equals -1. So that's our first answer. And then the second one, -10 minus 8 over 2. -10 minus 8 is -18 over 2 is -9. So our 2 answers there, x is going to be equal to -1 and -9. All right, so our next one, Now we've got a little algebraic work to do. So the first thing I need to do, I need to make sure that one side of the equation is equal to 0. That means I have to treat this like a two-sided equation and add this 3 to both sides so that this cancels out and is equal to 0. That makes the other side, 2x squared minus 5x plus 3 equals 0. And this is where I'm going to get the numbers for the quadratic formula. All right, so my a value is 2. My b value is a negative 5 because it's minus 5. And my c value is positive 3. Now let's just plug it in and go. If you want to pause and try that one on your own and then check in a minute when you're done. All right, so negative of negative 5 is positive 5 plus or minus the square root of negative 5 squared minus 4 times a times c all over 2 times a, which is 2. If I plug all of this in, now be sure if you're squaring this negative 5 to put it in parentheses, otherwise you're going to get negative 25 when you square that, and negative 5 times negative 5 is positive 25. So what we should come up with when we simplify the radicand is 1, and then 2 times 2 on the bottom is 4. So that means this is 5 plus or minus 1 over 4. So our two answers, one of them is 5 plus 1 over 4, which is 6 over 4, which you could have as 1.5, but I would encourage you to try to answer in an improper fraction. So reducing the fraction, both are divisible by 2. That makes this 3 over 2. And then the second one, 5 minus 1 over 4. 5 minus 1 is 4 over 4, which is 1. So our two answers there, 3 over 2 and positive 1. All right. Go ahead and pause the video and give this one a try. It's already in standard form. It's just that the numbers are a little bit bigger now. Let's see if you can come up with it. All right, so A is 6, B is 11, and C is negative 35. That means this is negative 11 plus or minus the square root of 11 squared minus 4 times 6 times negative 35 all over 2 times a, which is 6. All right, plugging all of this in, you should come up with a bigger number. Negative 11 plus or minus, I want to say it's 961, but I could be wrong about that. Maybe it's 931. No, 960. I think it's 961. Over 12. Now, we're going to get some problems in examples 5 and 6 where you get a square root that doesn't reduce. It's not a perfect square. This one is. It's just not one that's easily recognizable, which is why I'm trying to remember what it is off the top of my head, because I remember that whatever this number is supposed to be, when you actually take the square root, it's supposed to be 31. So I think it's 961. So that's what we should come up with. Then the answers are negative 11 plus 31 over 2. That is what, 12. 20 over 12. Both of these are divisible by 4, so that would reduce to 5 over 3. You could also use 1.6 repeating. Then negative 11 minus 31 over 12. That is negative 42 over 12. Both of these are divisible by 6, and that becomes negative 7 over 2, or negative 3.5. So your two answers there, 5 over 3, negative 7 over 2. All right. go ahead and pause once I have this erased and try this one. Now notice it's not equal to 0 on this side, so what do you have to do first before you figure out your A, B, and C? All right, so hopefully we remembered I have to subtract 5 from both sides to start with. And now it's 2x squared minus 3x minus 5 equals 0. So my A value is 2, B value is negative 3, and my C value is negative 5. Again, be careful with the signs with these. That's a really common mistake. You drop one negative and it screws the whole thing up. All right, so the negative of negative 3 is positive 3, plus or minus square root of negative 3 squared minus 4 times 1 times negative 5, all over 2 times 2, reducing what's in the square root, 9 plus, oh, this should be a 2 rows. Like this should work out to be a nice number. So it should be 3 plus or minus the square root of 49 over 4. Square root of 49 is 7, so 3 plus or minus 7 over 4. So our two answers, 3 plus 7 over 4 is 10 over 4, both divisible by 2, so that is 5 over 2, or 2.5. And then 3 minus 7 over 4, that is negative 4 over 4, which is negative 1. So our two answers are 5 over 2 and negative 1. All right. If you want to pause now and start the homework, not a bad idea. Come back to these last two examples, though, because some of these problems are not going to have nice square roots that reduce, and if you can do the nice ones, that's good enough to like still do okay on the assessment. But if you want to be able to get like all of the problems right, you're going to need to be able to answer some problems in radical form. So think back to the first couple weeks of the semester, quarter 3, quarter 1 or quarter 3, and when we were working with square roots and stuff like that. Okay, so this one, it's in standard form already, so I can just take and say that A is equal to 1, B is equal to negative 4, C is equal to negative 8. And I can start plugging in. Negative 4 is positive 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 8, all over 2 times 1. So this ends up reducing to 4 plus or minus the square root of 48 over 2. And if you plug the square root of 48 into your calculator, it probably gives you 6.9 something, a bunch of random numbers, because this is an irrational number. What we need to do, if it's not a perfect square, like the previous 4 examples, is reduce this. We need to simplify this square root. The square root of 48, if we factor it out, 4 and 12, 2 and 2, 4 and 3, 2 and 2, so we make our factor tree, and then remember you're looking for groups of 2 with the square root. I have 2 groups of 2, so 2 times 2 is 4, and then the one I didn't circle was the 3, so the square root of 48 is equal to, it simplifies to 4 times the square root of 3. So that means this is going to be 4 plus or minus 4 root 3 all over 2. Now, if I'm looking at this, it's not quite all the way simplified because the terms on top are both have a 4 with them and the denominator is a 2. Both of these are divisible by 2. So this, the 4 divided by 2 is 2, plus or minus, and this 4 divided by 2 is also 2. So 2 plus or minus 2 root 3. And the nice part about these is you can just leave them like that with a plus minus, and that's your answer. All right, so take a look at this last one, pause, and give this one a shot. Again, not in standard form, so what do you got to do with that 9 first? And then resume the video when you're ready to check your answer. All right, so hopefully we remembered, subtract 9 from both sides. X squared minus 4x minus 9 equals 0. That means that A is 1, B is negative 4, C is negative 9. So very similar to the last one, but a little different numbers. So this is going to be 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 9 all over 2 times 1. This is going to then reduce to 4 plus or minus the square root of 52 all over 2. Square root of 52, if we factor that out, is 4 and 13. So we've got a single group of 2. So the square root of 52 is equal to 2 times the square root of 13. That means this is 4 plus or minus 2 root 13 over 2. Everything on top is divisible by 2. 4 is divisible by 2. 2 root 13 is divisible by 2. So 4 divided by 2 is 2 plus or minus 2 root 13 divided by 2. The 2's cancel out, and it is root 13. So 2 plus or minus root 13. All right, take a look at the homework, the worksheet, and the Canvas quiz. And don't forget, feel free to email or send a screenshot of any problem that you have a question on to your teacher, and we'll be happy to get back to you.